All right, this is the difference quotient worksheet, and then I also have some free response practice for that question number 3 that we talked about. So this says find and simplify the difference quotient. If the function is linear, you shouldn't have work to show. Remember, the difference quotient represents the slope of a secant line. A secant line is just the slope between any 2 points on a function. If the function is linear, then it doesn't matter which 2 points you pick, the slope will always be the same. So that's why I say you shouldn't have work to show. But if the function is nonlinear, the slope will change depending on which 2 points you're looking at. So you need to have the difference quotient memorized. The formula is f of x plus h minus f of x all over h. Now take a look back at the notes if you want to know where that formula comes from, but we're basically just finding the slope between 2 points, and they are h units apart. All right, so we need to begin by just setting this up. So what does f of x plus h mean? It means you're plugging in for the input the expression x plus h. So instead of 2x squared, it's 2 times x plus h squared. Instead of minus x, it's minus x plus h. So when you're subbing in that expression, always use parentheses. So we have that. And then we have minus f of x. Now f of x, so here's let me kind of separate this out. Here's x plus h, f of x plus h. Here's f of x, back to regular 2x squared minus x. And then the whole thing is over h. You don't have to use these square brackets that I'm using. I just kind of like doing that because it really separates things out. We basically have 3 things that that are a part of this equation. F of x plus h minus f of x all over h. This formula, by the way, super important for calculus. It is the beginning of derivatives, which is the first thing we'll learn about. Now, what's the rest of this? The rest of this is just careful algebra. So when you square a binomial, you should get x squared plus 2xh plus h squared. Distribute this negative through, minus x minus h. Distribute this negative through, minus 2x squared plus x. All of this is over h. Do not skip writing the over h part, because when students do that, technically you're writing down a false equivalence. It's not correct that these 2 things are equal if you don't have the over h, but also you tend to forget to actually divide by h. Distribute the 2 through. Now, if you can do that and combine like terms at the same time, that's great. I'm not going to. This would become 2x squared plus 4xh plus 2h squared. The rest of this I'm just going to keep copying down. Minus x minus h minus 2x squared plus x. All of this is over h. Now, if you have done the math correctly, the algebra correctly, anything that doesn't have an h on it should cancel out somewhere along the line. So 2x squared positive cancels with negative 2x squared. They add up to 0. Minus x plus x also adds up to 0. Everything else has an h that's left over in the top. And so our final step is to divide everything by h. Or also what you're doing, if this helps you, you're factoring an h out. You don't have to show me this step, but if you factor an h out of all out of all of these terms, that's what you're doing when I say you can divide by h. Or you can also just say, yeah, I'm going to divide each of these by h and get down to my final answer. So my final answer for the difference quotient, the slope of the secant line, is 4x plus 2h minus 1. This just means, by the way, if I tell you, okay, find the slope between the point that's sitting at x equals 5 and a point that's 10 units away from that, you could plug in 5 for x and 10 for h and tell me what the slope between those 2 points are. So it's a formula. Eventually, we use this for this formula for the slope of a tangent line. That's what derivatives are. Now, number 2, before I dive into f of x plus h and whatever, this is a linear function. So actually, I don't need a formula. I can just say, well, what is the slope between any 2 points on this line? The slope is the number that's being multiplied in front of x. So m secant is equal to 3/5. If you do the math correctly, you should, with difference quotient formula, you should get down to 3/5, but there's no need to waste your time doing that. I would prefer to see you not do the work, because it means to me, it means that you kind of understand what we're finding every time we do this. All right, number 3, we have a cubic. So this is going to take a little bit of work here, or we can use a shortcut too. First, I need to plug in f of x plus h. So instead of x cubed, x plus h cubed. Instead of minus 3x, minus 3 times x plus h. So that's f of x plus h minus f of x, which is just x cubed minus 3x. That whole thing is over h. Now, cubing a binomial, you can go ahead and FOIL it out times itself 3 times, or there is a shortcut to this. I can't remember if we talk about this, excuse me, in the notes or not, but there's something called Pascal's triangle. Pascal's triangle starts with a 1 at the top, and then ones like this, make a little triangle. And then every row after this starts with a 1 and ends with a 1, and then any numbers in between, like 1 plus 1 equals 2. This one will be 1, 1 plus 2 equals 3, 2 plus 1 equals 3, then you end with a 1. If I had to keep going, it'd be like 1, 4, 6, 4, 1. You could do this, infinitely many times. What does this represent? This represents, let's do x plus h. X plus h to the 0. This represents x plus h to the first. This represents x plus h squared. And what do I mean by represents that? What do we get when we square a binomial? We get x squared plus 2xh plus h squared, right? That's what this is saying. 1, 2, 1. 1, 2, 1 are the coefficients in front of those terms. And then you just have to know the pattern for the exponents. Every term, the exponents add up to 2 in this one. For here, every term, the exponents will add up to 3. This is x plus h cubed. So let's write out what it would be. It would be 1x cubed plus 3. And then what's it going to be? I need the exponents to add up to 3. They always sort of cascade down. So this will now be x squared. And that means I just need an h to the first to get a degree of 3 for that term. There's another 3 here, so plus 3. And then instead of x squared, we're going down to x to the first, which means we need an h squared to get degree 3. And then end with a 1, h to the third. So this is what I get when I do this one. Just for fun, let's just do this one. Why not? This is x to the fourth plus 4. It's going to cascade down x to the third, so we just need h to the first because now we're going degree 4 for every term. Plus 6x squared. You always go down by 1 on the x's, which means you're going up by 1 on the h's. Plus 4x to the first, h to the third, plus 1, h to the fourth. See, so kind of fun. And what if you don't have x plus h? What if you have x minus 3? Well, then the h is a negative 3. Or what if you have x plus 2 or something? Then the h is a 2. What if it's 2x? Well, then put in a 2x in all of those. So it's kind of a nice formula. It saves you from foiling a bunch of stuff. You still have to do a little bit of math to simplify if they're not just x's and h's, but kind of nice. Okay, anyway, x plus h cubed is x to the third plus 3x squared h plus 3xh squared plus h to the third. I'm going to distribute the negative 3 through here, so minus 3x minus 3h. Distribute this negative through, minus x cubed plus 3x. All of this is over h. Again, don't be lazy about that, because if you write equals and you don't have the over h, you just wrote a false equivalency. They like to ding you for that on the calculus exam. Anything that doesn't have an h on it should cancel out somewhere. So positive x to the third minus x to the third, minus 3x plus 3x. Everything else has an h. And I can factor the h out again to cancel, or I could just go ahead and divide everything by h. It doesn't matter to me how you show the work. I just want you to understand what's happening. So you are allowed to divide every term. Oops, see, I almost lost track of one. I do that sometimes. So you are allowed to divide everything by h, but our final answer should be 3x squared plus 3xh plus h squared minus 3. For difference quotient, I'm not going to give you something higher than a cubed term, but for our AP test, they like to give us binomials that are raised to higher powers, and they'll ask us about just one of the terms, like, find the degree 3 term, because h will be a number, and what's the coefficient in front of that. So we'll practice that a bit more. All right, what about this next one? F of x equals 8. Now, that's not linear. It's not 8x, so the slope is not always 8. What does this mean? F of x equals 8. It means no matter what the input, f of x is always 8. The output is always 8. That's a horizontal line, right? So what is the slope of a horizontal line? No rise, all run, m equals 0. So the secant slope between any two lines would be 0. If you were doing difference quotient, f of x plus h would be 8 minus f of x, 8 over h. That still comes out to 0. All right, we have a quadratic here. So 3 minus x squared. So we do need the formula for this one. 3 minus x plus h squared. So that's f of x plus h minus f of x, just the original equation, all over h. Okay, now that's equal to 3 minus parentheses x squared plus 2xh, don't forget the 2, plus h squared, minus 3 plus x squared. All of that's over h. Distribute this negative through. 3 minus x squared minus 2xh minus h squared minus 3 plus x squared, all over h. Anything that's not an h should cancel. Plus 3 minus 3 minus x squared plus x squared. We can factor an h out if we want to. Negative 2x minus h. You could factor a negative h out if you want. I'll just leave it like that. So m sec is negative 2x minus h. What about this last one? It doesn't quite look linear, but this is not an x down here. So this is a degree 1 equation. Divide each term by 6. 2x over 6 plus 5 over 6. If you do that, it's more familiar. 2 over 6 is 1/3 times x plus 5 over 6. If I gave you this problem originally, hopefully you would recognize, oh, that's linear. So same thing here. This is linear. So that means that the slope between any 2 points on that line is not 2, but 2 over 6, which is 1/3. So just remember to look out for linear equations and simplify the slopes before you report what they are. Now, onto the back of this worksheet, I wanted to practice some of these free response questions. We will have a lot of time to review at the end of the year, but I just wanted to make sure that we saw this nice and early, because some of these questions, the parts of the questions are quite easy to do. All right, so this is free response question number 3 out of 4, and you're going to have, this is part C, parts I and double I, or 1 and 2. So part A, we will be responsible for putting these numbers in, but let's say we've already figured out what these numbers are. So the graph of H and its dashed midline for 2 full cycles are shown. We have these points F, G, J, K, and P. No scale is indicated, no axis is presented, but we went ahead and found the possible coordinates. So this is already done. There's nothing to do for that. I'm just giving you this so you'll see what it looks like. So say we were very smart and correctly found all 5 of these points. Part C, again, these are just like free points, it feels like. So this time we're looking at the coordinate on the graph of H. We're looking at the coordinate K and P. So this section here, K to P. Which of the following is true about H? Remember, this is Y values only. So it's the fact that we're going from K, which is 3 over 2, to P, which is 3. Those two numbers are positive. K is positive, so we can cross out C and D. Is this section of the graph increasing or decreasing? It's increasing, so this time the answer is A. Describe how the rate of change of H is changing. Now, you have to write this specifically. I'm going to script this for you guys because I don't want you to lose the point just because you weren't specific enough. So always say it like this. H is it concave up or concave down on K to P? That's concave down. Concave down looks like a frown is another way to kind of think about that. So H is concave down. So you need to say this, rate of change. Can't just say it. You need to say, so rate of change is concave down goes with decreasing. So concave down, rate of change is decreasing. If you just say concave down decreasing, you probably won't get the point. If you say H is concave down and decreasing, that's wrong because now you're talking about H. So you specifically have to say this. There's nothing you can really cut out besides the word so, maybe. All right, same thing, new points. So now you can see our points are listed here. This time we're looking from, excuse me, J to K. Here's J, here's K. This section here. So what about those y values? We're going from negative 13 up to negative 9. So those are both negatives. So H is negative. I'm crossing out A and B. And we're on a section that's going up, so increasing. Now what about concavity? This section is concave up. So I'm going to say H is concave up. Rate of change is concave up goes with rate of change increasing. It takes a bit of studying to remember what you're supposed to write, but you are writing the same thing every time. This is 2 out of 6 points that you should be guaranteed to get on problem number 3. All right. Okay, please come into office hours if you have questions or want any extra practice.